Power, Idiot's Guide.
So, welcome to the Idiot's Guide on nuclear power. Whoa.
I think nuclear power is a really good idea.
Do you?
Yeah, I do. Yeah.
Yeah, so do I. I mean, if we used other fuels...
You don't, do you?
Don't. I know, I don't think nuclear power is a good idea. I changed my mind very suddenly. Because if we had nuclear power and we used it, we'd have to put like the waste in large containers underneath the sea, buried underground. And if they broke, like all the fish would turn radioactive and like...
We wouldn't have any more fish.
No, we wouldn't have fish. Wouldn't be able to have fish and chips if it burst.
But then again, the amount of power that we get from radioactive technology and the amount of energy we'd get, we'd be able to make our own fish.
Out of sandpaper. No. Yes, but it's a windy day. See, we could just harness the wind in our environment.
I know, yeah, but then we'd have ugly wind farms out there.
They have wind farms in Holland.
I know, yeah, but Holland's an awesome place, so...
Well, England's an awesome place. You can have wind farms in England.
I know, yeah, but it just doesn't look right, because Holland's not natural, whereas England is.
Holland's not natural.
No, because it's an artificial country.
Fair enough. But still, we need to find different clean ways. Yes, there's no real bad products apart from like the uranium, which just had its half-life and stuff. Just people walking. Yeah.
We just cut this bit out, shall we?
Yeah. I'm not even in the screen.
Yeah, that's what I was thinking.
Yeah, I need to move in a bit, don't I? Okay. Okay, so me and Henny decided we need to take this a bit more seriously. So we went to Darlington and we met Brian Duncan, the Director of Operations and Maintenance at Darlington Nuclear Power Station. He decided that he wants to speak to us a bit and teach you a bit about how the nuclear power station works.
This huge building you see behind me is one of Ontario Power Generation's nuclear power generating stations. In essence, it's a factory that converts the energy of the atom into a flow of electrons, or what's commonly called electricity, the electricity that helps power the province. Nuclear, hydroelectric, and fossil fuel generating stations have many similarities in the way they generate electricity. Where they differ is their fuel source. OPG's nuclear stations use naturally occurring uranium that's processed into little ceramic pellets like this. An unused fuel pellet emits very little radiation. However, it holds the potential to produce a whole lot of energy. Just 8 of these pellets will power an average house for almost 1 year. The fuel pellets are sealed into metal tubes, which are then welded together to form a fuel bundle. Several thousand fuel bundles are then inserted into a large tank called a calandria, which is the heart of the nuclear reactor. Nuclear generating stations split the uranium atoms in the fuel in a process called fission, and the result is the release of a tremendous amount of heat. To unlock the heat energy in the uranium atoms, you need what's called a moderator. In CANDU reactors, a special kind of water called heavy water is used as the moderator. Heavy water is 10% heavier than ordinary water because it contains a higher than normal proportion of deuterium, which is a form of hydrogen. The heavy water surrounds the fuel bundles and slows down tiny particles called neutrons, so they are more likely to hit and split the uranium atoms. A chain reaction of atoms splitting ensures there is a constant source of heat to heat the heavy water. The heated heavy water is pumped through the reactor in a closed system to a set of boilers, where it boils ordinary water into high-pressure steam. The heavy water, having done its job, is recirculated back to the reactor to pick up more heat and cool the fuel. The high-pressure steam, made from ordinary water, is transported through pipes to a large turbine, where it pushes the blades and turns the shaft connected to a rotor in the generator, causing the rotor to spin. The spinning rotor is a large electromagnet that produces a rotating magnetic field. This field moves across coils of copper wire in the generator stator, producing electricity that can be sent across transmission lines. The steam coming out of the turbine is condensed back into water using cooling water from the lake and pumped back to the boilers to continue the process. Ontario Power Generation's nuclear generating stations have sophisticated safety systems to control, cool, and contain the process each step of the way, generating electricity safely and virtually free of all smog and greenhouse gas emissions.
Environment man here. Nuclear power. Cooling tower right behind me. Nuclear power, how sweet. Emission free electricity for me. I once was anti-nuclear, but now I'm pro-nuclear. Was blind, but now I see. 'Twas 3 Mile Island that taught my heart to fear, and Chernobyl my tears relieved. How precious did that dome appear the hour I first believed. When nuclear waste has been there 10,000 short years underneath Yucca Mountain. Sing Yucca's praise, and when reprocessing begun, nuclear power, how sweet the dawn, emission-free electricity.